Now we would like to start the next session. Mr. Itakura Keiko is from Shimane Prefecture, and Izumo City is where she was born and brought up. And she is actually knowledgeable in IT, management control, Japan Unisys, Japan Microsoft Inc., Japan IBM Inc. are the places where she worked. The Rakuten Group as well. After those places, and she is now in this current position in Med Group, and she is in charge of controlling the IT system. And Alliance and Fight Japan Working Group and Vice Chairman was Vice Chairperson was on her position, and she promoted that the passkey utilization across the world. She will discuss the passwordless implementation. Now, Mr. Itakura, could you please start your presentation? Thank you. My name is Itakura. So my career has been introduced, and so I will not dwell on that. And rather than talking about my company on a neutral position, I would like to give the most up-to-date information about the passless and authentication. It's not only about Ruby, but actually passkey is what. And so I would like to talk about it, and rather briefly, I would like to talk about the overall circumstances. The introductory part. So what sort of challenging matter have we faced in authentication and history? I think it is quite well known when it comes to the password challenging matters. So this is a dog. So by somebody taking over that an account, incident could happen in the operation. Password and authentication is causing some increase in the operational cost. That is some headache for various businesses. What about the two-step authentication? Even if it is two-step and it is broken down, it has been reported. For example, fake site is created and then password and is stolen, and some intermediary is an attack could happen. Usability. Once a password is actually registered and SMS received, and you actually key in that code. So usability has got some complication issue too. In order to resolve this two-step matters, passkey hasn't appeared. Passkey as a word is known and also used in various places, so I would like to make sure we have gotten the same understanding about the definition. In the FIDE Alliance, all the information is passkey, so all authenticated information is in a passkey. For the past 10 years, passkey has been used. The conventional passkey was actually device-based passkey. It was all tied to certain devices. And what about the next one, web browser? And so businesses have got an RP server between the two, and there is a communication and WebAuthn, and the browser versus and actually the authentication device and the CTAB. So between the two parts and the two-step and the authentication is that two files are involved. So what about an actual verification of the same person and identity? So it is done on the client side. So Touch ID and also fingerprint and also PIN is entered, and then the authentication is achieved. And then the one pair is prepared so that the public key, and this key pair is created, and so the verification of the self and the identity is given back to the server. It's not like a password or authentication. The confidential information is not escaping. And also on the part of the server, the authentication is done for other devices. So this is a one-step approach. PIN and also the two-element based authentication is achieved. What about the authentication devices? So the external devices possible by more recent times, and actually smartphones and also PC has gotten those authentication devices. So there is no increment in price as well. Even if a two-step is done, phishing might attack and also it is broken. In the case of passkey, both by self the ID authentication, it is actually that the identifier is a device. So unless it is in the same domain, the authentication is never achieved. So if a fake server is created, then there is actually resistance to that. So this is a history. Last year, think the passkey has appeared last year, so I would like to talk about it. It is device-based passkey. Number one, account recovery is one issue. So file is based on that authentication device. When the authenticator is lost, how can we actually recover the account? That has been always actually the issue. In order to resolve that, backout terminal can be registered, and for the recovery, password authentication should not be able to be eliminated or deleted. So these are the issues we had to address. And then I think the passkey was announced. The key can be actually on the passkey. So this is a conventional on the left-hand side. On the right-hand side, this is actually sync the passkey. Once passkey is created, device users create the key, and also it is encrypted in the Google Cloud and the passkey, and providers it is actually backed up. Then it is stored in the safe place, secured place. So there are several accounts in the same cloud, and they can use the same. So this is a Mac and OS, and another, by using another iPhone, I can use the same passkey. When you change the device and also you lost the device, and account recovery is much easier. What about the synchronized device? So the intermediary cannot read that information. In the case of an Apple iCloud keychain is a very basic, and the synchronization covers various devices, end-to-end encryption. Even if an Apple person, that information cannot be actually stolen. So this is actually the brute force attack, which is actually protected against brute force. When it was announced Apple and Google platform vendors could be actually passkey providers. More recently, one password manager companies can be involved. Third-party passkey providers have appeared in the market. I do not dwell on the details, but conventionally, only the determined specified device should be allowed for the access. And that is a requirement. So device-tied authentication information can be actually used. It is an optional. I would like to talk about related technology. First one is an automated input. If you want to log in certain site, user ID list can be given, and among them, passkey is also actually shown. Therefore, user password, it does not have to be entered. User ID doesn't have to be, but you can choose from those options. And then you can actually log in. This is a smartphone. Smartphone can be used as an authentication device. It is an authenticator. Windows PC, Chrome is used for the login, and iPhone is used for the authentication. So multiple platforms can be used. This is a Bluetooth technology-based approach. I would like to show you some demonstration. It is actually perhaps better, easier for people to understand. This is the registration UI. Depending on the businesses, they vary, but the user ID is entered. Sign up button, you click it. In the next screen, create passkey button is here. So you can read those the notes. So your biological information is only stored in your own device. That is actually notes. After all, passkey is actually to place the public key in the cloud. Therefore, biological information will be staying in the device only. Create passkey is now clicked, and Touch ID might be required. So you can see that in the Pop ID. And if you actually present your fingerprint, passkey registration is complete. It is now slowing down. So this is what you can see on the screen. User ID is entered and the fingerprint only. Then account registration is now complete. And the user authentication. So user authentication should happen. User ID entry form is actually chosen. The cursor is here. So cursor list is presented. This is an autofill, automated entries. I used to be actually I used to have that an account. Therefore, I have two. So which an account would you like to use? So you can actually present your fingerprint and by Touch ID. It's not working so smoothly. Then authentication complete. At the time of that, the user ID does not have to be entered. It was actually iPhone I used in here. So this is an account, and the PC can be used and for the login based on the same ID, and Windows PC is used and as a device. And then this is actually an authentication demonstration screen still shown here. On the PC, you try to have the authentication user ID castle on it, and in other devices, and you would like to log in. So you can see that on the pop-up, and you choose that, and then a QR code is on the screen. By reading that and with an iPhone, by using that an iPhone key, you can actually log in on the PC. It seems to be working okay. This is an iPhone screen. This is a hybrid, Bluetooth-based technology, and across platform, a passkey can be utilized. This is a very simple UX, and then you can actually achieve what you want. So there are many advantages, and what do you have to be careful about? And so actually there are different parties and involved for the responsibility. In the case of a single passkey, it's not your own company's server, but actually the passkey providers will keep it. The passkey providers are secured, so there is some potential risk, and so the risk and initiation price is different. In order to keep a passkey, there were complicated procedure. But in the case of passkey, only the public and the key is in the server. Therefore, even if it is stolen, the secret and the key can be actually applied. You cannot. Therefore, so when the servers and information is actually broken and stolen, there is not so much negative impact. And also the usability is very important. More recently, synced passkey is used by many companies. Password and passkey providers can be various parties or businesses, which password providers is actually responsible for the passkey management. That is an important point. Passkey providers information in AGU, and this is an ID. You can use that in the identifier to get their information. This is actually the common utilization of that. An airdrop is used, so it can be actually shared with other parties. Therefore, depending on how to use that, there could be potential risk. Single passkey is in the transitory period. Therefore, depending on the vendors, there might be some variance. In this site, you can find more detailed information. Hybrid is one approach, and a third-party passkey provider can be used. Now, I would like to talk about an implementation of passkey in Ruby, on Ruby. WPC and so API is used. And then this specification is a public domain, so including backend processing, you can understand how things are working in what way. A Ruby library is also in the public domain. Multiple ones are possible, and therefore you can use them for the implementation process. When passkey is implemented, primarily passkey registration and also authentication process are necessary. There are two implementation procedures. Revocation and others might be involved, but as far as the core functions are concerned, there are these two major ones. Two APIs should be prepared, and then 6 steps are necessary to you go through. Number 3 and number 4, the authentication device and also browser, so that you can actually depend on that. The developers don't have to think about it in the actual implementation procedure. Library is used, and so the WebAuthn should be actually added for the installation. And there are various libraries in addition to WebAuthn. Therefore, depending on the library and its nature, you can choose. So this is actually the domain name, RP number, and also this is actually these are to be set up, and also timeout and can be set up as additional setup. So this is the flow. User passkey is actually clicked, and that is the first click. So given that the trigger names and also the various account information are required, so that is sent to the server. So user request for the registration, the challenge is actually prepared. Passkey authentication is based on the challenge system, so replay attack is actually prevented from depending on how they do that. RP information is necessary. Together with that, the public key credential object is created. Inside this object, an essential element is necessary: server information, user information, and a challenge. And the RP acceptable credential types are to be necessary. And although not essential, authenticator selection is actually presented. So that is optional.
This is how implementation is done. For user, the information entered by the user is taken, and for create options, you prepare public key credential creation options object is created. And important matters, authenticator selection, there are various options. For user verification, determines whether authentication of the person is necessary by authenticator, and require resident key is also an important item. Unless it is true, autofill cannot be used. Default is false. So you have to select true, not false. If it is left as false, and you might allow the user name entered like UX, and authenticator attachment is used to restrict the types of authenticator. Unless that is set, arbitrary authenticator can be used, and when that is used as a platform, then authenticator embedded into the subscriber unit can be used. So by changing the parameter, user will receive a pop-up for selecting the authenticator to be used, or UX changes like the case when Touch ID was required, and also the timing to wait the entry by user and origin of authenticator should be verified or not can be specified. And then using object and public key as an argument method is called up. Now, WebAuthn JSON can be used, and the JavaScript library, there are various ways. And about the way to call up the method, JavaScript should be used, and Authn JSON, easy to use the library exists. When you call up a WebAuthn method, there is a dialog for authentication, and then Touch ID or fingerprint presentations for authentication shall be done. And once that is completed, RP information as a key pair of private and public keys are generated, and using attestation key signature should be given. Attestation is an important mechanism for passkey authentication. Authentication result on the main device is done. So the authenticator itself needs to be the valid authenticator. Otherwise, the verification result cannot be valid. So for authenticator to prove that that is the right authenticator, attestation secret key, private key is stored in a safe region, and then we use the key for signature. And once the key pair is generated, the private key is stored internally, and the public key and the public key credential information are returned to browser. Attestation object and the current data JSON are read on the part of the server, and attestation object is the information about attestation, and a client data JSON. For instance, the information about origin or challenge are contained in array buffer format from browser. In JavaScript, a result is given to RP. On the part of RP, a returned object decodes and pass through to JSON, and value can be obtained on JSON format. And such a passing can be done easily with the use of library. And object sent is stored as an instant, and that contents is verified. For instance, client data JSON challenge and challenge required by the server, whether they match or not, can be compared. Once the verification is over, user.credential.build is to be used, and information necessary for authentication, such as the public key information, are stored in a database, and the failure or success will be shown on the user's display through browser, and then challenge in the session is deleted. For registration, and authentication step is more or less similar. As in case of registration, first is the authentication request from the user. Autofill function, if you want to use that auto-complete attribute, WebAuthn should be added. WebAuthn and username are designated in this case, and also username for ID and password login can also present as candidates. Once a request from the user is received, a server creates a challenge, and public key information stored in DB will be stored in allow credentials, and public key credential request options object is prepared. And the method of implementation is more or less the same with the time for registration. Call up, create a necessary object and challenge. And inside objects, challenge is essential, and allow credentials needs to be specified so that usable public key credentials can be limited. For instance, for transports, by specifying that area, the method of communication with authenticator can be specified, be it USB or NFC or hybrid. In that case, hybrid is the only method allowed. For hybrid, there aren't many things to be considered in development. If there is no passkey within the device, then automatically options to use passkey other devices are activated. For registration, navigator.creation.create is executed as the method, and for authentication, get method is activated. And the way to call up mediation conditional, by adding this autofill function, it can be designated usable. Then authenticator create assertion after confirming the user based upon the information of challenge and relying party. The assertion preparation is the same with attestation at registration, but the public key information is not included in assertion. And authenticator then returns the authenticator data to browser. And within the public key credentials, authenticator attestation response was included in the object for registration, but for authentication, this will be authenticator assertion response. Process number 5 is more or less the same. Our response from authenticator is given to RP in JavaScript. Authentication data and client data JSON are used for verifying assertion signature. Client data JSON verification is the same with registration, decoding, taking up the contents, and see whether the challenge matches or verify origin and type. For authenticator data, decoding, take out the data and verify the result of user sync and user verification. For signature verification, authenticator data and the client data hash, connected data, and the public key stored in database are used for verification. Implementation. This is the same as the case of registration. Client data JSON challenge value and the value in the session, whether they match or not, is verified. And user verification flag, is it correct or not, is confirmed and verified. Once verification is finished, stored credential update. Here in the middle is where data in the database is updated. For instance, the number of signature counter in public key credential and also the date of last use is updated. And then the result of verification, whether that was success or failure, is returned to browser. And challenge used is deleted from the session. And that's the end of authentication process. I have gone through very quickly. Some of the points were difficult to digest. I'd like you to look at the information later for further details. This is a good technology, and a library publication is gradually being developed, but passkey provider safety and to confirm which data are tied to are the areas you need to pay attention to for sync passkey. And with this, I hope you'll be able to execute the risk analysis case by case. Now, modern technical implementation. Important point is how to migrate from the current authentication experience. And UX guidelines are already made public, so please pay attention to that and read it later too. Thank you very much for your kind attention.
Now, we would like to entertain some questions from the audience. If you have any, could you please raise your hand? So this is the time for entertaining some questions addressed to the speaker. I'm afraid that there is no question among the audience, so this marks the closing of this presentation session. If you have any question which you would like to ask of this lady, and Ms. Itakura, could you please have another opportunity this evening? Now, could you please give a big round of applause to Ms. Itakura to express our sincere thanks. Now, this marks another conclusion of today's program, covering all the agenda and so programs. Thank you very much for your support. As for the receiver for the translation, would you mind returning it to the receptionist desk before leaving this place? If you have parked your car in the car park of this hall, there is actually the free of charge car park ticket, and please get it in the exhibition hall on the way home. There is a reception tonight, and if you have applied for that, there is actually a token voucher for the reception to participate in by 6:30. Could you please come and gather in the exhibition hall on the ground floor? And tomorrow, the program is starting at 10 o'clock in the morning. Thank you very much for your kind support, and this marks the conclusion of all the programs today.